Okay, so this is a video key for the review on graphing quadratics, transformations, and average rate of change. All right, so starting off with problem number one, our job is to basically graph the parabola, and we're going to go through and calculate all of the parts of the graph. So starting off, it's asking us for the vertex. All right, so we're going to start off by actually finding letter B, which is the axis of symmetry. So to find letter B, we're going to say the formula negative b over 2a. And we know that because we're doing a problem that is in standard form where we have a, b, and c, right? So we can actually use a, b, and c. So we're going to say in this case negative 4 over 2 times 2, which looks like negative 4 over positive 4, which is negative 1. So I'm going to say my axis of symmetry is at negative 1. And so what that means for us is that the graph shifted over 1 unit, and it's right now sitting right here at negative 1. Okay, so we put down an axis of symmetry because we know half of the graph will be on the left and half of the graph will be on the right. So to find the vertex, I know the vertex is actually on the axis of symmetry, so I'm going to say it's negative 1 comma something. And to figure out what that something is, we actually want to know what's the y. So that means I'm going to plug in negative 1 for x. So I'm going to say the y is equal to 2 times negative 1 squared plus 4 times negative 1 minus 5. Okay, and so if you go through and simplify this, we get negative 1 squared, which is 1, times 2, which is 2. 4 times negative 1, gotta grab my eraser, okay. 4 times negative 1, so this was plus 4, okay, is negative 4 minus 5. Okay, so this is 2 minus 4, which is negative 2. Negative 2 minus 5 is negative 7. So that I know that when I plugged in negative 1, I got negative 7 back, which means I can go to my graph and say, I can go over to negative 1, down to negative 7, and that is my vertex. I'm going to label it on the graph. I'm going to say this is the point negative 1, negative 7. Okay. Now I need to find the other critical point. So the y-intercept, you have two options here. For standard form, it's actually just the c value. So remember, negative 5 is c, and it's 0 comma negative 5. If you don't want to remember that rule, remember what a y-intercept is. It's a point on the y-axis, which is 0, 1, 0, 2, 0, 3, 0, 4, something like that. All of the points have a 0 in the x position. So you can also go to your equation and say, I know that for this particular point, there's a 0 everywhere that I see x. So I'm going to say this, okay, is the plug-in. And when you simplify this, you actually get 0 squared times 2. Well, that's 0 plus 0 minus 5, which is negative 5. So that's kind of getting me to the same place, but without having to remember a special trick about this problem. All right, so you can always go back to the rule which says for y-intercepts, plug a 0 in for x, and whatever comes out for y, that's where it crosses the y-axis. So again, we're going to go over to the graph. Negative 1, negative 2, negative 3, negative 4, negative 5. That's right here. And again, I'm going to label it 0, negative 5. Okay. The x-intercepts are the opposite of the y-intercept. So in the y-intercept, we have a 0 in the x position, which means we can find y. So for this one, we're actually going to do the opposite. We're going to put a 0 in the y, which will let us find x. So we're going to go to our equation, and we know that it's something, comma, 0. And we're going to go plug a 0 in for y and find out what I can put in that space. So I'm going to say 0 equals 2x squared plus 4x minus 5. Okay? And so you have to go through the process of solving this equation. And you can use whatever method you want to solve this equation. We could try factoring. We could try the quadratic formula. You could use completing the square. So you can use whatever method you prefer to do this. Right? I believe this is a factorable equation. Let's see if we can figure out what it is. So we'll check. AC is negative 10, and my B is equal to 4. So I would need to find numbers that multiply to negative 10 and add up to 4. So if I'm going through the list of things that multiply to 10, okay, I'm going to say 1 and 10, 2 and 5. Well, it doesn't look like either of these pairs add up to 4, which means I can't actually factor this one. I could only factor it if I could find 1 plus 10 or 1 minus 10 is 4. Nope. 2 plus 5, 2 minus 5 doesn't work either. So I actually can't use AC factoring. So we're going to have to go back and use the quadratic formula instead. Okay, so I'm going to use quadratic formula, and we're going to say negative 4, negative b, plus or minus. And again, I like to come off to the side for b squared minus 4ac, so I don't have to have a big plug-in step. So b squared minus 4ac, in this case 4 squared, which is 16, and it would be 4 times 2 times negative 5. So negative 4 times 2, well, that's negative 8. Negative 8 times negative 5 is going to be positive 40. Okay, so that looks like 56 when I add that together. So it's 4 plus or minus the square root of b squared minus 4ac came out to be 56 all over 2a, which is 2 times 2. Okay, so we can go to a calculator and type in negative 4 plus the square root of 56, and we can get an exact number, or a rounded number that we could actually plug in. So negative 4, if we go to the calculator and type in the square root of 56, we're going to get something around 7.5. About. Okay, so if I do negative 4 plus 7.5, that comes out of this, I'm going to get 3.5. And it's 3.5 over 4. Okay, that's one possibility. The other one is, well, I could get negative 4 minus 7.5. Okay, when that looks like it's going to be negative 11.5 over 4. Okay, so we want to go to a calculator and we want to type in 3.5 over 4. That's going to come out to be something like 0.8. When I type in negative 11.5 over 4, again, it's not exact, but it's going to come out to be something a little less than negative 3. So, sorry, negative 3 would be negative 12 divided by 4 would be negative 3. So something a little less, like negative 2.8, something like that. Okay, so I can go to my graph, and these are estimates. Your calculator might give you 0.7 or 0.6, but it should be around there. All right, so I'm going to go and I'm going to say, okay, positive 0.8 is about right here. And here's why I don't really care. You can't really tell the difference between 0.8 and 0.7 or 0.5. They all kind of look the same. And then if I go to negative 2.8, that would be negative 1, negative 2.8. Okay. So I actually want to check real quick, and I want to make sure that this makes sense. Okay. I'm going to go over 1 and a little bit, right? And that hits that point. If I go to the other direction, I'm also going to go over 1 and a little bit to get to the other point. So I have symmetry here. I'm going over 1.8. And the other way I'm going about 1.8. So this is a good set of x-intercepts. So I'm going to say it looks like 0.8 comma 0 and negative 2.8 comma 0 are my x-intercepts. Okay, so that's 4 points now. So again, I'm just going to label these. I'm going to say this is 0.8 comma 0, and this one is negative 2.8 comma 0. Okay. So I have two sets of points there. So if you take a look, I'm really starting to get a nice parabola out of this. The last point that I need is the point symmetric to the y-intercept. And all that really is we're saying, remember this idea of symmetry, if the y-intercept, if I can count over just one unit to get to the axis, that means that there's another point, 1 unit, right on the other side. Okay, and if I look, I can count over and say negative 1, negative 2, down to negative 5. That looks like the symmetric point is negative 2, negative 5. And I'm going to label that. Okay, so I want to be able to show them all on my graph. Okay. So there you go. I have all of the points that they asked me to graph, right? And I'm just going to make sure that I actually draw the parabola as best as I can. Okay, and I'm going to do the same thing on the other side. Okay, so I have an approximate graph of this parabola. Okay, so that's what your parabola should look like. And again, you have a couple little checks. I checked symmetry. I have a 1.8 and a 1.8. Right, same thing down here. Everything's centered really nice on the axis of symmetry. And I have also an indication right here that I should get an opening up parabola. It's a positive 2. Positive 2 means no reflections. So it makes sense that I'm opening up here. So everything's checking out. It looks like I have a good parabola. Okay. So the last question I'm getting here is asking on what interval is the graph decreasing? And what that means is as I'm traveling this way across the graph, which side or where on the graph is the parabola going downhill, right? And if you take a look at this little tail right here, all the way until we get to the vertex, it looks like from negative 1 heading this way, right, heading up and to the left, that's where it's going downhill, right? So this half of the graph, the left-hand side of the parabola, that's where it's decreasing, because as I'm traveling across the graph from left to right, it's going downhill right there. So I'm going to say it looks like when the x values are less than or equal to negative 1, that's where it's decreasing. I'm going to make a little change to that. We're going to say x is less than negative 1, because at negative 1 it's actually that's where it turns. So we want to be a little bit more specific. X is less than negative 1. So we're saying the graph is going downhill until it gets to negative 1, and then it turns around and starts going back uphill, right? So if I changed it and I asked where's the graph increasing, we would say x is greater than 1 or negative 1, because that's where it's heading uphill. Okay, so that's the idea of increasing versus decreasing. Okay, so your second problem is asking you to do the exact same thing. We need to find all the critical points. Okay, it's just that our problem now is in vertex form instead of being in standard form. Okay, so the nice thing about this is when they ask me to calculate the vertex and the axis of symmetry, no more negative b over 2a, because I can actually say this is an h value, this is a k value, and the vertex is always h comma k, So I can just plug in, well, h is 3, and be careful, it's not negative 3 because my formula is x minus h squared, okay, plus k. So I can actually say the h value is not negative 3, it's actually positive 3. Okay, and my y value is negative 2. So let's put that on the graph. I'm going to go over to positive 3. I'm going to go down to negative 2, and there's a point right there. Okay. The axis of symmetry is by definition x is equal to h. Remember that x value in the vertex is also the axis of symmetry, so in our case it's x equals 3. Okay, so I can put the dotted line down as well, and I can say, okay, there's a graph. If I start right here, okay, that's where the center of my parabola is. Okay, you got to be careful though, because the y-intercept is not negative 2. The y-intercept is actually, we have to plug in, right? So if you remember, we said all y-intercepts, the x is 0. So I'm going to take my problem and say y is equal to a half times 0 minus 3 squared minus 2. And I need to simplify this. So I say 0 minus 3 is negative 3. Negative 3 squared is 9. Half of 9 is 4.5 minus 2. So this is turning into 4.5 minus 2, which is about 2.5. Okay, so I'm saying I plugged in a 0. I got back a 2.5. So that's my y-intercept. So I'm going to go over to my graph. I'm going to go up 2.5, and there's a point there. Okay. Let's do the symmetric point since we're talking about y-intercept. So if I'm at my y-intercept here that I just graphed 0, 2.5, I can go over 1, 2, 3, and that hits the axis of symmetry. That means I can go to the other side, 1, 2, 3, and there's another point right in the middle of 2 and 3. Okay, so that's my point symmetric. So that looks like the point 6, okay, 2.5. Okay. And so that would be my point symmetric. So it's just counting boxes over. If you notice, there is always this relationship, double the vertex ends up here, because we're kind of counting over to the vertex and then again. So if you happen to notice that and you want to use that, you can, but you don't have to. You can always just count boxes. Okay. So let's find the x-intercepts. X-intercepts hasn't changed. We're still saying I want to find a 0 in this position. Okay. And so put a 0. I'm sorry. I want to find out what x is. So I'm going to put a 0 in the y spot. So I'm going to say 0 equals 1/2 x minus 3 squared minus 2. Okay, so this is actually a square root method problem. So I need to add the 2 over. So it's going to be 2 equals 1/2 times x minus 3 squared. Now I need to get rid of a half. To get rid of a half, I can multiply both sides by 2. So this is going to become 4. Okay, and it's going to become x minus 3 squared. Okay, now I can square root both sides. When I square root 4, I get 2 answers. I get 2. Or I get negative 2, okay, and then the rest of the problem is just going to be x minus 3, right, because I square rooted away the squared. So here are my 2 answers. When I add the 3 over, it looks like I get a 5, x equals 5 is an answer, and when I add it over here, it looks like I get a 1. Okay, so I'm going to say in this case 5, 0, and 1, 0. Those are my 2 x-intercepts. So let's go to the graph and make sure they make sense. So 1, 0 is right here, 5, 0 is right here. Okay, and again, I'm going to go through and just check and make sure this works. If I count 2 units to the left, I hit an x-intercept. There's another one 2 units to the right. Good, that works out. That's the way we want it to be. That's symmetrical. Okay, so let's just label these real quick. It looks like I had the point 3, negative 2. Okay, I had the point 5, 0. Okay, I had the point 6, 2.5. I had the point 0, 2.5. And I had the point 1, 0. Those are my 5 critical points that they asked me to graph. Okay, let's draw our parabola. Okay, a little bit wider than our last one because that 1/2 made it get a little wider. All right, so it should look a little bit wider than the last one we drew. Okay, and then on what interval is it decreasing? Well, again, we want to know as I'm traveling this way across the graph, it looks like it's going downhill until I hit 3, right, when my x value is 3. So I'm going to say when x is less than 3, that's where you're going to see the decreasing part of the graph. Okay, so very similar to the last one. We just have to watch out for how we find the vertex in the axis of symmetry, how we calculate the how we calculate the y-intercept, and making sure we use the square root method for the x-intercepts. It's a different solving method. Okay, so let's move on and let's talk about transformation. So for each of these problems, we need to determine what A, B, C, and D are. We need to list what they do, and we want to just draw a basic sketch. And then we're going to use the sketch to find the domain, the range, and the vertex. Okay, so in this case, my A is negative 2. My B is not there because that would be in front of being multiplied by x on the inside. So there's a 1 in that spot. So 1 times, we wouldn't see. Okay. C in this case is -5 and D is +4. Okay, so we need to list what each of these things does. Okay, so I'm going to start off with A, and we're going to say A does two things. A does a reflection over X, okay. And the 2 is bigger than 1, and when our numbers get bigger than 1, it makes the graph narrower. So the graph's going to get narrower. Our parabola in this case. Narrower. Okay, so that's what A does. It actually does two things. The sign change reflects the graphing it. The 1 getting bigger, which in this case it turned from 1 into 2. That's a larger change. That's going to make it get narrower. Okay, my C value is going to move it to the left 5 units. Okay, and my D value is going to move it up 4 units. Okay, so if you remember, I'll just draw it kind of right in here. Our parent function is just right at the origin, and then it turns around. It opens up. Okay, so what we're doing is we're transforming this by using this list. So I'm going to go to my sketching area, and I'm going to draw a coordinate plane. We don't need to label it. This is a sketch. It's a rough estimate of where everything's going to look. So I know that instead this is going to be upside down and a little skinnier. Okay, so it'd kind of be here now. It's going to move to the left by 5 units. So instead of being at 0, 0 like it was, it's going to be over here about 5 units. And then it's going to go up 4 units. So it's going to kind of be like this. Okay? And this is our rough estimate. Again, nothing exact. But we know that the vertex moved over to the left by 5 and up by 4. And it's kind of sitting in that space there. So the domain for all quadratic functions is all real numbers. We can move it around as much as we want, and that's not going to change. In this case, my range did change. This one was y is greater than or equal to 0. But now it moved from 0 up to 5. I'm sorry, up to 4. Okay, and we also flipped it over, so it's going to be y is less than or equal to 4. Okay, and my vertex is going to be at -5, +4. Okay, which we can kind of see that it's going over to -5. It's going up 4 units, and that places it right there. Okay, same thing with the second one. Problem number 4. We're going to say my 0.25 is A. B is 1 because I don't see it, and when I'm multiplying by 1. We never see that. C is also missing. When I add and subtract 0, I don't see that. So because B is a multiply number, the one that makes it go away, the one that makes it not be seen is 1 times 1 makes it just what I see when I'm adding 0 or subtracting 0. Right? That's why this one, we don't see either of those, but for B it's 1 and for C it's 0. D in this case is -10. Okay, so I only really have 2 transformations here. I'm going to say this one, the graph is going to get wider. Okay. And that's because my A value, neutral is 1. Okay. When I increase from 1, it gets bigger. When I decrease between 0 and 1, it gets wider. Right? So it goes above 1 narrower, below 1, all the way down to 0. That makes it get wider. Okay. And there's no reflection in this case because it's positive. And then it looks like D is going to make it go down 10. Okay. So if I look at my graph, my sketch, not a whole lot's going to change here. It's going to start at 0, 0, just like it did. It's going to be a little bit wider than it was, so we'll kind of bring it out more. And it's going to be way down bottom, right? The vertex just moved down by 10 units, and all the other points followed it, right? So my domain, again, always everything. Okay, my range is going to be y is greater than or equal to 10, because that's where the vertex is. And my vertex is at the point 0, comma, -10. I'm going to change that. The range is y is greater than or equal to -10. Okay, and I'm going to say that my vertex, let me fix it. Okay, my vertex is the point 0, comma, -10. Okay, so we just use the information A, B, C, and D to determine the vertex and to determine the domain and the range. Okay, one more of these types of problems. Okay, problem number 5. We're going to say A is 3, B is 1, C is 5, D is -6. The transformations are getting narrower because of the A value. Okay. We are moving to the right by 5. Okay. And we are moving down by 6. Okay. So that's all we have to do. Remember, B didn't change anything. We listed everything. There's no reflection because A didn't become negative. Okay, so now I'm going to sketch. It looks like it's going to look like a skinnier version. Move to the right by 5 and down by 6. So it's going to kind of look like this. Okay. And we can't really show narrow all that much, so don't worry about that too much, okay? So my domain is everything. My range, y, is greater than or equal to -6. And it looks like my vertex is at the point 5, comma, -6. Okay, so that's just a quick summary. Very similar to both of the other ones that we did. Problem number 6 is asking us to, on the same coordinate plane, graph this transformation. So I'm giving you this function. We're calling it f of x. I'm not telling you where it comes from. Doesn't matter. And I'm giving you 4 points that are on the graph. And I'm saying I changed f of x, which was the parent function, into this new one. So again, think about a, b, c, and d. I'm going to say a is -1. Okay. B doesn't exist, so I'm not even going to list it. C is -1 as well. And my d value is +2. So if I were to describe this in words, I would say reflection, left 1, up 2. So let's do that. Reflection, okay, is going to go from +3 down to -3. I need to go left 1, and then I need to go up 2. So I just did all of those things. And so this point right here is now moved down to -1, comma, -1. I'm going to do that for each of them. I went from 1, 4. I need to reflect, which means now we're down at -4. I'm going to go to the left by 1. I'm going to go up by 2. There's my new point. Okay. The point at 4, comma, 5, I need to reflect, which means it's going to come down to -5. It's going to come to the left by 1. It's going to go up 2. There's my next point. And 9, 5, I'm sorry, it looks about 9, 6, I guess that is. I'm going to take that down to -6. I'm going to go to the left by 1, and I'm going to go up 2. And if you notice, I'm getting pretty much exactly the same shape, okay? But it's changed by exactly what we described. It's reflected, it's shifted over a little bit, and then that reflection shifted up a little bit as well. Right? So I would just show these points, and that would be enough to complete this problem. Okay, problem number 7. Now we're moving into average rate of change. So just to remind you that the official definition that I gave you for average rate of change was that if we're given 2 x values, so if I call this one x and I call this one a, right, and I'm saying this is the interval from x to a, and that I'm going to subtract those. I'm going to say this is x minus a on the bottom. How much did the x values change? On the top, I'm going to compare what is the output from x, which we can look at the table and tell that, okay? And I can do the same thing for a, right? So these are kind of what we used to call y values, right? They're output values, but now we're calling them f of x and f of a. So I'm finding the difference in the inputs, and I'm finding the difference in the outputs. And in this particular problem, I can actually just use the table of values. They're saying, in this case, we're using r of x instead of f of x, but same idea. I can say that the average rate of change on the bottom of the fraction, I'm going to start at -4. I'm going to end at 0, okay? And I'm going to say, well, what is the output for -4? I can go over to the table, and well, -4 goes to 3, okay? And I can do the same thing for 0. 0 goes to 2, so I'm going to say 3 minus 2. So this one looks like 1 over -4, okay? So I would say the average rate of change of this interval is -1/4. Okay, so now I'm asking you a second question. I'm saying now that you know that it's 1 over -4, which you can write a bunch of different ways. I could call this -1/4, or I could put the negative on top, and it could be -1/4. All of these kind of mean the exact same thing. It's just where I put the negative sign. Okay, so when this says, what does the value describe about the steepness of the line and its direction over the interval? So we're saying, on average, okay, so I'm going to use this word on average because this is an average rate of change. We're saying, on average, okay, the graph is decreasing, okay, and I know it's decreasing because it's negative. Doesn't matter how you write it, this is a negative fraction, so we're saying on average the graph is decreasing over the interval. It might not be decreasing everywhere, but it's more decreasing than anything else, okay? So on average it's decreasing, okay, and that's what I'm talking about, the direction over the interval. We're saying it's going downhill, okay? And we can say, and as we change, okay, the bottom of the fraction represented x, so as we change x by 4, okay, as we change, I'm not going to change this, I'm going to say, as we decrease, okay, -4 would mean a decrease of 4. As we decrease, okay, x by 4, okay, we increase y by 1, right? So we're saying, remember, bottom is x, top is y, so I'm saying, as we decrease x by 4, 1 is positive on top, so we're going to increase y by 1. Okay, so that's our way of describing in words what this average rate of change is telling us about the graph. Okay, Problem number 8. Same idea. I want to know which function has the higher average rate of change over this same interval. So I'm going to set up two functions. I'm going to say, all right, we have r of x. Okay, let me try that again. Okay, we have r of x. And we have another one called t of x. Okay, and so I need to calculate the average rate of change of each of these and then compare them and see which one has the higher average rate of change. All right, so we're going to say same problem, -4 minus 6, right? This is the interval. They asked me to go from -4 up to +6, so I'm using those as the values for the x. I'm going to use the same interval for t, -4 minus 6. Okay. The only thing that's going to be different about these problems is what is the output at -4 and what is the output at 6. And to figure that out, we need to go back up to the equation. So I'm going to say when I plug in a -4 here, I'm going to get -4 squared, which is 16. I'm going to plug in a -4 here. I'm going to say -5 times -4. That's 20 minus 7. So when it looks like when I plug in a -4, I get 36, right? That's what comes from when I add these together. 36 minus 7 is 29, okay? So let's do the same thing again with 6, okay? When I plug in 6, I'm going to get 6 squared, which is 36. -5 times 6 is -30 minus 7. So that looks like 6 minus 7, -1. And be careful, there's a minus sign in the formula, and I'm inputting a -1 for f of a, right? So I need to include both of those, so be very careful with that. So it looks like on the top I get a 30, okay, and on the bottom I get a -10, okay, and that's going to be simplified fraction, -3, and I'm going to say -3 over 1. I like to do that because now I can see the change in x and I can see the change in y as well, okay? So let's do the same thing with the other side. When I plug in -4 into this function, it looks like -4 squared, which is 16 times -3. Okay, well 16 times -3 is going to be -48 minus 8. Okay, well -48 minus 8 is -56. Okay, I'm going to do the same thing for 6. When I plug in a 6, it looks like 6 squared, which is 36. 36 times 3, we'll just do that real quick. That looks like 108. So this is -108 minus 8. Okay, so I'm going to simplify that, and -108 minus 8 is -116. Okay, so I'm going to plug that in. -116. Okay, so now I need to simplify again. The bottom still -10. The top it looks like is going to be, again, I got to do plus plus. So I'm going to come off and just make sure I check this. 116 minus 56. Okay, well that's going to be 60. Okay, so I'm going to say on top when I simplify these, it looks like I'm going to get a 60. Okay, so the average rate of change here is 6 over -1, okay, or -6. Okay, so if I'm comparing these numbers, and this is where you have to be careful, I'm going to say which one has the higher average rate of change. In this case, I'm going to say t of x wins. Okay, and you might be thinking, well, this one's -6 and this one's -3. Isn't -3 technically bigger than -6? And my answer would be yes, absolutely it is. The problem is remember the negative is telling us about the direction. So in this case, we're saying these are both going down, right? Because they're both negative, on average decreasing. Okay, but it looks like 6 would make it decrease faster. That's a bigger number than 3 is. Okay, so you have to be careful. What we call is we can put in another word in here. We call it the absolute value, okay, rate of change, right? The bars. We're actually comparing how steep the numbers are, and since 6 is going to cause it to decrease more quickly because it's a larger number, we're going to say that that is the higher rate of change. So don't look at the sign. Sign is just telling me about increasing and decreasing, but the actual number itself, 6 is the bigger number, so we're going to go with that. That is the higher average rate of change. So we're going to say t of x has the higher average rate of change just from the interval -4 to +6. Okay, a couple more problems. Problem number 9, it says calculate the average rate of change over -2 to 4. It sounds a lot like the one we just did, except now when I'm setting up my equation, again, bottom is still the x values, -2 minus 4. Well, that looks like -6. Okay, I have to figure out what y value goes with -2. The way I'm going to do that is I'm going to go to my graph. When I go to -2, looks like I'm going to go up to 5. So I'm going to say -2 comma 5 is a point. When I go over to 4, I also go up to 5. So in this case, it looks like 0 is my average rate of change. It's just how I got the points that are different from the last problem. The last one I had to plug into an equation to get them. This one I need to look at the graph to get them. Same calculation. One more problem, same idea. I'm looking at a strange looking graph and I need to find the average rate of change. So I'm going to say -7 minus 6. That goes on the bottom. Those are the x values. If I go over to -7, it looks like I go up to this point right here, which was 5. Okay, and when I go over to +6, it looks like I hit at 0. So I'm going to say 5 minus 0. So in this case, it looks like 5 over -13, and that would be my final answer. Nothing to simplify there. Okay. All right, last problem. It says, using the graph from problem number 9, which I've included here, the same one that we calculated average rate of change, it just wants us to identify some points. So I'm going to look at this and I'm going to say, okay, what is the vertex? The vertex is where the graph turns. That's the point 1, -4. 1, -4. Okay, and then I'm going to say, what is the axis of symmetry? Be careful, don't just say 1. It's not 1. It's a vertical line, and we're going to say it's the equation x equals 1. You need that x equals, or you're not describing anything that I know about. Okay. Problem number, or letter C, is saying what are the x-intercepts? We can just identify them. That's 3, 0. Okay, and that is -1, 0. Okay, so I'd say those are my two x-intercepts. Y-intercept is down here at 0, -3. Okay, the reflection point is this point right here, 2, -3. Okay. And what is the equation of the parabola in vertex form? So this is the tricky one. So let's take a look at what it should look like when we're done. We're not going to plug anything in yet. We're going to say it should look like a x minus h squared plus c. This is what equations look like. I'm sorry, plus k. Okay, this is what equations look like. So I'm saying this is what it should look like when we're done. We just need to fill in these three values, a, h, and k. Remember, we're not going to fill in x or y because those are like the ones that need to be in the equation when we write it. Okay, so I'm going to actually look at this and say, well, h and k, well, those are the vertex. This is an h and a k. So let me plug those in. So I'm going to go to my equation and I'm going to say h is 1, so it's -1, okay, and squared, and it's -4 on the outside because my k value there is -4. Okay, I don't know what a is, so I kind of can't finish this. I need to figure out what a is. The nice thing is I have a bunch of x comma y's on this graph that I can use. Obviously, I don't want to use the vertex again. I've already used that one, but I can pick any of these other points. So I'm going to pick this one right here, 2, -3. We're going to find out what happens. So I'm going to put this in. 2, y is the -3, and I don't know what a is. Okay. I can calculate a now. This says 2 minus 1, which is 1 squared. 1 squared is 1. This whole thing turns into 1, and I'm saying 1 times a is a. -4 is equal to -3. Okay. If I add this 4 over, it looks like a is going to be 1. Okay. So if I write my equation now, I'm going to say, here's what I know. Y equals, a is 1, so I'm going to write it there just so you can see it. X minus my h value, we've already said is 1 squared. My k value is -4, -4. So here is the equation. I just needed to calculate my a value using an h and a k, and using an x and a y from the point, so that the only thing that was left was my a value, and that let me solve for it. Okay, so that is the entire key. That is every problem that is on the review and that will be on your test.